So, a very good afternoon to all, right? So, my voice is audible and my screen is also visible to all of you. Please confirm me once, and after that, we are going to start our session. So, quick screen visible, hai? Hmm? Right? Okay. Good evening. Right. Very good. So, what we are going to do in today class, right? So, in this class, we are going to quickly revise alcohol, phenol, and ether. And in Sunday, that is in tomorrow class. Today class also, we are going to do some numericals related to alcohol phenol ethers. We are going to solve some questions, basically some PYQ questions of JEE Mains and NEET. And in tomorrow class, that is in Sunday, we are also going to do previous year question of both NEET as well as JEE Mains, right? So this is what we are going to cover. I hope you all study alcohol, phenol, and ether, right? So I'm going to quickly revise all this thing that is very important, right? And by understanding this thing, you are able to solve numericals for we say questions, right? Because this is organic chapter, so it doesn't contain any type of numerical, so it will contain some PYQ questions. So we are going to solve some question related to method of preparation, their chemical properties, their physical properties, right? So this is what we are going to do, right? Clear है सबको? अपना plan clear है आज का, right? So my name is Vivek, okay? And today we are going to discuss alcohol, phenol, and ethers, okay? So basically, this is also known as that is a carbon containing oxygen compound, right? So in some book, this chapter can also written as the carbon containing oxygen. So in carbon containing oxygen, we have a basically in this we have a two chapters, right? The first chapter in which we are going to study the alcohol, phenol, and ether, and in the next chapter we are going to study the aldehyde, ketone, and carboxylic acid, right? So both are carbon oxygen chemistry, right? So in this lesson you will study about the compound containing carbon and oxygen single bond, right? That is COH, where in the next class, that is in next classes, we are going to study the aldehyde, ketone, and carboxylic acid, where we have a double bond between carbon and oxygen, right? So among the compound with the carbon oxygen single bond are the classes of alcohol, phenol, and ethers, and they having the following general structure that you all know, right? सबको पता होगा ये अल्कोहल को हम लोग ऐसे रिप्रेजेंट करते हैं, that is ROH, where R is any alkyl group, right? And phenol can be represented at this where alkyl group is replaced by the benzyl group, right? And ether, that is ROR dash. So this R dash may be R or maybe a different alkyl group, right? So these three things that we are going to discuss in this chapter, that is alcohol, phenol, and ether. So in the first part, we are going to discuss alcohol and their method of preparation and their chemical properties. After this, we are going to discuss phenol and ether, right? I hope सबको clear है यहाँ तक? किसी को कोई doubt है यहाँ तक? किसी को कुछ भी doubt हो बेटा तो you can ask, right? You can just text me in a chat box and I'm going to reply each and every query. So if you have any doubt related to anything you want to understand, you can ask, right? यहाँ तक सबको clear है? जल्दी बता दो एक बार. Alcohol, phenol, and ethers. Their general structures of alcohol, phenol, and ether, right? Now, how will you classify and the nomenclature of alcohol? So we all know that we can classify alcohol based on the primary alcohol, secondary alcohol, and the tertiary alcohol. So many times children get confused in remembering what do you mean by the term primary alcohol? What is this secondary alcohol and what is this tertiary alcohol, right? So always remember this: when only one alkyl group is attached to the carbon, which is attached to the OH group, right? So if only one alkyl group attached to that carbon, which is attached to the OH group, then it will said to be primary alcohol. और अगर उस कार्बन पे दो alkyl group लग जाए, that is two R and this R, then it will become secondary alcohol. और वहां पे अगर तीन तीन alkyl group लग गए, तो that is called tertiary alcohol. So I hope this is clear है, सबको clear है ना? For example, agar someone, if someone asks you, can you classify this? That is CH3, CH2, and this is OH, right? And in this we have a CH3, we have a CH, we have OH, again CH2 and CH3. So what is this, right? And Which one is a primary and which one is a secondary alcohol? Can you classify better? Yes. The first one is a primary alcohol because in this only one alkyl group is attached to this. Where this one, because in this the C, that is, we can also write a structure like now, that is CH3 and this is nothing but CH. This is OH and this is again CH2 and CH3. So how many alkyl group it attached to that carbon atom? That is one and this one. So this is called secondary, right? So this is an example of secondary alcohol, where this is an example of primary alcohol. So I hope this is clear. How will you classify primary, secondary, and tertiary alcohol? Hmm? Clear, सबको? Sure. Good. So there are some common alcohol and their names, right? So you must know if I'm talking about the primary alcohol, so we have a two name, right? One is called IUPAC naming and other is called their common name, right? So two name we have, basically what you need to remember is IUPAC name only, right? But there are some important common name also, so you need to remember, because many times questions are coming directly by its common name. So if you know the common name, then you can easily solve the question, right? So I'm going to share some important common name of the compound so that you can remember and you can just utilize this thing. Okay. So what is primary alcohol? So basically, if I'm talking about, this is nothing but OH, right? This is OH. Okay. So if someone wants you, what is the name of the given compound? So we know that the numbering starts from the functional group, that is 1, 2, 3, and 2 we have a one substitute. So that is called 2-methyl and propanol, right? So this is called 2-methyl and propanol. So this is their IUPAC naming. Always remember this thing. This is their IUPAC naming. So what is the IUPAC naming of this? That is 2-methyl propanol. What is the common name? So we can also say that isobutyl alcohol. So always remember this. We can call it isobutyl alcohol. Similar, this is known as benzyl alcohol. So their common name is benzyl alcohol. So always remember this. This is called benzyl alcohol. Okay. Good. In this we have, yeah. Good. So this is called benzyl alcohol, right? Now, this is also known as IUPAC naming like 1-propanol, and we can write their common name like 1-propyl alcohol. Okay. Similarly, if you want to name the secondary alcohol, on the same base, we have a propane 2-ol, butane 2-ol, and cyclohexanol. So these all are the IUPAC name. Now, what is the common name? So propane 2-ol is also known as the isobutyl alcohol. This is called secondary benzyl, right? This is butanol, right? So this is called butanol. That is secondary butanol, right? This is not benzyl, right? Correction in this. This is not the benzyl alcohol. Okay. Now, this is known as a cyclohexyl alcohol. Okay. So this is how will you name. So just remember some common name and their secondary alcohol, primary alcohol, and the tertiary alcohol. So on the similar basis, this is known as a tert butyl, right? This is nothing but tert butyl. This is tert butyl alcohol, right? This is not benzoyl. This is called tert butyl alcohol. This is name is 2,3,3 trimethyl ethane butane 2-ol, and this is known as the 1-methyl cyclohexane 1-ol, right? So these are the some common alcohol and their naming. So always remember this thing. So there is a correction in this. This is do not known as benzyl alcohol. Instead, they are known as butyl alcohol, right? So ये butyl alcohol है. This is called secondary 1, 2, 3, 4. So this is secondary butyl alcohol, right? So their name is secondary butyl alcohol. Okay, and this is cyclohexyl alcohol. Clear है सबको ये? Now, let's see some important method of preparation of alcohol. That how will you prepare alcohol? ठीक है? कैसे हम alcohol बनाएंगे? Okay. So the first method by which you will prepare alcohol is nothing but a hydrolysis of haloalkanes, right? So in the last chapter, we are discussing about the haloalkanes, right? So haloalkanes is what? RH, where R is any alkyl group and X is any halogen compound. So by the hydrolysis of haloalkanes, we prepare alcohol, right? So what is the reaction for this? So haloalkane can be converted to corresponding alcohol using aqueous sodium, or we say potassium hydroxide, or a water as a nucleophile. So always remember this thing. So when you treat CH3, CH2Cl or anything, alkyl halide with NaOH aqueous, always remember this NaOH aqueous, not alcoholic. If you take alcoholic KOH or alcoholic KNOH, then the beta elimination reaction will be formed. Alkene will be formed, right? So always remember this. You will take aqueous NaOH or KOH. So when you treat CH3, CH2, Cl with NaOH, what will form beta? This NaCl will be removed and CH3, CH2OH will be formed. This is known as the nucleophilic substitution reaction, right? We already discussed their mechanism in the alcohol halogen chapter, right? In alkyl halide or haloalkane chapter already. Now here we have a 2-bromobutane. So we have a 2-bromobutane. Now when we treat with the aqueous NaOH, what will form? It will form butane 2-ol, right? It will form butane 2-ol. So this is the first method for the preparation of alcohol directly by the hydrolysis of haloalkanes. Anyone having any kind of doubt related to this method of preparation? किसी को कोई भी doubt है अभी तक? पूछ लो एक बार. Clear है? How will you prepare alcohol by using hydrolysis of haloalkane? Is it clear to everyone? Right? Okay, chalo. So this is the hydrolysis of haloalkanes. Now, from hydration of alkene. So this is also a very important method for the preparation of alcohol, right? From the hydration of alkene. So hydration means what? Simply hydration means addition of water molecule, right? So hydration means addition of water molecule. So in case of alkenes, hydration is the addition of H plus and OH across the double bond to give alcohol, right? Always remember this thing in case of alkene, because we know that alkene having double bond, right? And double bonded electron and loosely bonded electron. We all know this thing. So in case of alkenes, hydration is nothing but the addition of H plus and OH across the double bond to give alcohol. Now alkene can be hydrated by the following method. So in this we are going to study the two methods. One is known as acid catalyzed hydration and another is known as hydroboration reaction, right? So these two methods are very important for the preparation of alcohol from the alkene, right? Is it clear? If someone asks what is hydration of alkene, simply it means hydration means addition of water molecule, nothing else. Or in case of alkene, hydration is the addition of H plus and OH negative, because we know that water consists of H plus and OH negative. So hydration is the addition of H plus and OH across the double bond to give the corresponding alcohol, right? So let's see each method one by one. So the first one is acid catalyzed hydration, right? So what is this acid catalyzed hydration? So we have a ethene, right? So when this ethene is treated with H2SO4, right? We treated with H2SO4, what they will form? It will form ethyl hydrogen sulfate, right? It will form ethyl hydrogen sulfate, that is CH3, CH2, and this will form HSO4, right? So this is known as ethyl hydrogen and this is sulfate, right? So this is ethyl hydrogen sulfate. Now, in the next step, if we do the hydrolysis of ethyl hydrogen sulfate, what you'll get? You'll get ethanol, right? So this, always remember this thing. Here some correction like, if this H2SO4 attached, right? So this is attached to which compound? That is CH3 and this is CH2 and HSO4, right? So this is attached to this HSO4, right? Now on hydrolysis, what you'll get? You'll get CH3, CH2 and OH, right? So this is the correct way, right? This can't be possible. Na? CH3, carbon can't have a valency more than 4, right? So this is not correct. So this is the correct one, that is CH3, CH2 and OH. So this is the ethyl hydrogen sulfate and ethanol. So formation of ethanol will be takes place. So when the ethene is treated with this, the formation of ethanol will takes place. I hope this is clear. How will you prepare from this? Right. So let's see the acid catalyzed hydration. Again, some example of acid catalyzed hydration. Like the reaction proceed via the alkyl hydrogen sulfate, and this method is used for the industrial preparation of ethanol. Always remember this thing. The acid catalyzed hydration reaction is used for the industrial preparation of ethanol. In case of unsymmetrical alkene, the addition follow Marconi's route. So in the previous one, this is a symmetrical alkene, right? This is called the symmetrical alkene. But in case of asymmetrical alkene, the addition follow the Marconi's rule. So what is this Marconi's rule? So we all know that according to the Marconi's rule, if we have like if we have alkene like CH3, CH and double bond CH2, right? So if we have an alkene like CH3, CH double bond CH2 and addition of H2O, so we can write as, right? If the addition of H2O in presence of acid will take place, right? So we can write water as OH negative, NH plus. Hmm? No problem. We can write as OH negative NH plus. So according to the Marconi's rule, the negative part goes to those carbon atom of the double bond which contain the lesser number of hydrogen. Right. So this is the simple definition of the Marconi's rule. We already covered this thing in 11th class. Right. So according to the Marconi's rule, the negative part goes to those carbon atom of the double bond which contain the lesser number of hydrogen. So according to this negative OH negative goes to this carbon. So what will form? It will form CH3 CH, that is OH, and this is CH3. So this is known as propane to all, right? So this is known as propane to all, right? So this is the simple mechanism for the acid catalyzed hydration. In this question also, we have, CH3, CH3, CH2. So according to this H2O, we have one negative part and one positive part. So this negative and positive part goes to which carbon atom? So this negative part goes to those carbon atom which contain the lesser number of hydrogen on the double bond. So this carbon, right? This carbon contain lesser number of hydrogen on the double bond because this carbon contain two hydrogen. So this negative OH goes to this carbon atom, right? So this will become OH CH3 and this will become CH3. So the product become 2-methyl 2-propanol, right? So the product become 2-methyl 2-propanol. So this is the simple reaction. So always, whenever you have to prepare the secondary alcohol, always remember this. Wherever you have to prepare the secondary alcohol from alkene, always use this method, acid catalyzed hydration, right? So whenever you want to prepare secondary alcohol, from what? From alkene, asymmetrical alkene. Always you use acid catalyzed hydration. For primary alkene, this method won't work, right? This is only for the secondary alcohol. So what about the primary alcohol? Yes. So we have a different method like hydroboration reaction, and this is useful for the formation of the primary alcohol, right? So I hope this is clear. Sabko clear hai acid catalyzed hydration? Hmm? Anyone having any kind of doubt in acid catalyzed reaction, you can ask. Right? Clear? Good. Okay? Chalo. Very good. So this is all about the acid catalyzed hydration. Now, next is demercuration, also known as, the oxymeric demercuration reaction. So what is happening in this and what is basically all about this reaction? So in this, the alkene react with the mercury acetate. Remember this. In this, the alkene react with the mercury acetate. That is mercury acetate. We have a formula of mercury acetate like HgOCCH3 twice. So this is the formula of mercury acetate. So alkene react with the mercury acetate, also represented by HgOAC2, right? We can also represent mercuric acetate with the formula HgOSC2 in an aqueous tetrahydrofuran. So this is the solvent we use in this reaction, that is THF, also known as the tetrahydrofuran solvent, to give the hydroxyl mercury compound which are reduced to alcohol by the sodium boron hydride. Right. So this is a two-step reaction. In the first step reaction, oxymercuration takes place, and in the second step, hydroxyl mercury compound which are reduced to alcohol by the sodium boron hydride. So by the use of the sodium boron hydride, we reduce this, right? So let's see the step one. Step one is also known as the oxymercuration reaction, C double bond C, that is H2O. So when this alkene is react with the H2O plus HgOSC2 in the THF solution, that is tetrahydrofuran solution, what we got? Then we get chemical structure like we have a CC, right? We have a alkene. So C double bond C, right? So and this reaction with the H2O and mercuric acetate in presence of THF, that is tetrahydrofuran. So we'll get this C and this Hg and OAC. And what will form? That is CH3COH, acetic acid. Now in the this step is known as oxomercuration, right? So this step is known as the oxomercuration, because in this the mercury is added to the carbon, right? In this step the mercury acetate is added to the carbon atom. So this step is known as oxomercuration. Now in the next step, this mercury acetate is removed from this carbon atom. How it will take place? And this is also known as a demercuration, right? So this is also known as demercuration. How is this? Dekho. So we have a CCHONHG, right? So we have a compound like this, and this react with the NaBH4. This NaBH4 act as a reducing agent. This NaBH4 act as a reducing agent. And what they do? So they will form, right? Here we also have, right? Here we also have OH and right. Okay. Okay, so we have a HNH, right? So in this next step, when we react with NaBH4, what will form? This will form alcohol, right? This will form alcohol. So by the reduction or by the reduce of sodium boron hydride, alcohol will be formed. So this is the oxomercuration or demercuration reaction, in which the first step, the addition of mercury acetate takes place. In the next step, this mercury acetate will be removed by the presence of sodium boron hydride, which is reduced this to give the corresponding alcohol, right? तो फिर हम लोगों को क्या मिल जाएगा? Alcohol मिल जाएगा, जो alcohol हमें prepare करना है, right? Now this method give very good amount of alcohol, and here also the addition takes place according to Marconi's rule, right? So here also the addition takes place according to Marconi's rule. Let's see another example so that ये तुम लोगों को बहुत अच्छे से clear हो जाए. So now we have also one example, like we have a pent1ene, right? So here we have a pent1ene. So according to the Marconi's rule, right? So according to the Marconi's rule, what takes place? According to the Marconi's rule, the negative part goes to those carbon atoms which contain the lesser number of hydrogen on the double bond, and the hydrogen goes to those carbon which contain the more number of hydrogen on the double bonded. So here also we have a pent1ene. So a structure of the pent1 is like this. Now HgOAc, that is mercury acetate in the aqueous THF. So we have also aqueous like H2, right? So we also have a H plus and OH negative, right? So we have also have a H plus and OH negative. So this OH negative goes to which carbon, beta? Yeah, this carbon, right? So this like this, right? So this OH goes to this carbon atom, and this HgOAc goes to this CH2. Now again we treated with NaBH4. When we treat with NaBH4, what will form? This will form CH3, CH2 twice, OH, CH3 and plus H3. So that will pentane 2 all form. So this also follow the Marconi's rule of addition. Okay, so this method also give a very, very good amount of alcohol, and here also the addition takes place according to the Marconi's rule. Now what about the primary alcohol? Still the question arise कि primary alcohol कैसे बनाए alkene से? तो अभी तक हम लोगों ने क्या किया है? दोनों केस में secondary alcohol ही बना है, चाहे वो हम लोग बात करें oxymercuration reaction का या फिर acid catalyzed hydration का. In both the cases we form only secondary alcohol. So what about the primary alcohol? How will you form this primary alcohol, right? So let's see this. So for preparation of primary alcohol, we have a separate method called hydroboration, or we say hydroboration oxidation, right? So by using this method, that is hydroboration oxidation, we are going to prepare primary alcohol. So let's see how this reaction takes place. So when the alkene react with the BH3, that is boron hydride, in the again THF solution, and organoborane is obtained, right? In organoborane is obtained. How this obtained? Let's see this. So we have a structure like alkene, right? So this is a, we have a structure like propene. So we also known as a, proburane or something alkene called, right? So when this alkene is react with BH3, so we form the organoborane, right? Let's see with the example. Since BH3 has a 3 hydrogen, remember this point, very important. Since BH3 has a 3 hydrogen, above addition can occur 3 times. to give the trialkyl borane, right? Because in BH3 we have a 3 hydrogen, and in each alkyl group take 1 hydrogen. So we need 3 alkyl group, right? So since BH3 has a 3 hydrogen, and above addition can occur 3 times to give the trialkyl borane, and this is shown for the propane, right? So let's see if example for this. So now we have a propene, right? So we have a propene, and this propene react with BH3. So again, according to the Marconi's rule, so BH3, we can also write BH3 as H and BH2, right? H and BH2. So according to no BH and BH2. So according to the anti-Marconi's rule, right? According to the anti-Marconi's rule, or we say peroxide effect, the negative part goes to those carbon atom which contain the more number of hydrogen on the double bond. So this is the negative part. This is the positive part. So this negative part goes to which carbon? Yes, goes to this carbon atom according to the anti-Marconi's rule, right? So this BH2 negative is goes to this carbon atom which contain the more number of hydrogen on the double bond. So what will form? They will form CH3CHH, and this is BH2. This is called propyl borane. Now again this react with the CH3CH double bond CH2, that is propene, to form dipropyl borane. And again they react with the CH3CH2, so they will form tripropyl borane, right? So this is how the trialkyl borane will be formed. So this is clear? Sabko samajh aaya hai? How this propene will form tripropyl borane? How this trialkyl borane will be formed? Clear hai? Chalo. Now what after that? So now we have a trialkyl borane, right? So we have a trialkyl borane. So obtain the oxidized using alkaline hydrogen peroxide solution to give 3 molecules of alcohol and boric acid. So now this propyl borane, and this react with the H2O2 and OH, right? Oxidizing agent like hydrogen peroxide. So it will give the 3 molecule of propanol and the boric acid. So this is very, very important result we get. In this, we get the boric acid. So always remember this. In case of a hydroboration reaction, we get the boric acid, right? We get the boric acid. So whenever the tripropyl borane is react with the hydrogen peroxide and OH, what they form? They form propanol as well as the boric acid. Now, note here, the important note here. What is the important note here, beta? That is the hydroboration oxidation gives the anti-Marconic addition of water all through the reaction proceed according to the Marconi's rule, right? So this is all about. So I hope this is clear. This is clear to you. Okay, just give me a 1 second. Right. Yeah, someone. Okay. So this is how will you get this, right? So hydroboration oxidation give the anti-Marconic area. Always remember this thing. The first two method, that is the acid catalyzed hydration and the oxy-demercuration reaction based on the Marconic rule, and this hydroboration reaction is totally based upon the anti-Marconic rule, right? So in this we'll get the primary alcohol. So whenever questions are coming from how will you convert, that is alkene, and how will you, or we say how will you obtain alcohol from alkene. So if they want a primary alcohol, go for the hydroboration reaction. If they want, if they want to ask you about the secondary alcohol, always go either by the Oxymercuration reaction or the acid catalyzed hydration, right? In both these cases, you get the secondary alcohol. Okay? Sure. Now, this is very, very important react method again, that is the reduction of carbonyl compound. So by the reduction of carbonyl compound also we get this, right? So this is the reduction of carbonyl compound. So by the reduction of carbonyl compound, we also prepare this, right? So how will you prepare by the reduction of carbonyl compound? So carbonyl compound, what is carbonyl compound? Can anyone define what is carbonyl compound? Hmm? Anyone? What is carbonyl compound, beta? Yes, that we are going to study later. That is C double bond O, right? That is C double bond O is known as a carbonyl compound. It will be either be aldehyde or it will be ketone or carboxylic acid, right? So carbonyl compound which contains CO groups such as aldehyde, ketones, carboxylic acid, and ester, they can be reduced to alcohol, right? So now aldehyde give primary alcohol while ketone gives secondary alcohol on the reduction. So remember this thing, very, very important. That is aldehyde give primary alcohol while ketone give secondary alcohol on reduction. ठीक है? Chalo. So this is we have a aldehyde, right? So this is nothing but an aldehyde. So when this aldehyde is treated with a H2PD, right? So when this aldehyde is treated with a H2PD, then the reduction takes place. So what will form? They will form RCHOH. That is called primary alcohol, right? So what they will form? They will form primary alcohol. So this aldehyde convert into primary alcohol by the reduction of what? By the reduction of H2 or PD. Similarly, if you treat the ketone and the reduction of ketone will be takes place in the presence of NaBH4 and this will convert it into secondary alcohol. So always remember this thing, aldehyde reduced to primary alcohol. Ketone reduced to secondary alcohol. Okay? So by the reduction of carbonyl compound also we prepare alcohol, right? So we can prepare alcohol by the reduction of aldehyde and ketone. Now, carboxylic acid and ester also give primary alcohol on the reduction. So remember this thing. Carboxylic acid and ester also give primary alcohol, not secondary and tertiary. We get secondary alcohol only in the case of ketone. For the tertiary alcohol, we cannot get tertiary alcohol by the reduction of ketone or aldehyde, right? So let's see. So carboxylic acid and ester also give the primary alcohol. So we have a carboxylic acid and the reduction takes place in the presence of AlIH4. So when we treat with the AlIH4, this carboxylic acid will be converted into primary alcohol. Similarly, the ester will be converted into primary alcohol, right? So here, very important note here, which maybe come in your examination. Such points are very important. So you must remember this point, right? What is the? That is the reduction is carried out using hydrate reagents such as the lithium aluminum hydride and sodium boron hydride, right? So the reduction is carried out using hydride agent, that is either lithium aluminum hydride or sodium boron hydride. Always remember, lithium aluminum hydride is a stronger and react explosively with water, while the sodium boron hydride is convenience to handle and react slowly. Now, lithium aluminum hydride reduce all the above class of compound, while the sodium boron hydride reduce only aldehyde and ketone and does not reduce carboxylic acid and ester. Hence, it can be used to selectively reduce. So this point is very important. Just note this point. Like LiLH4 can be used for either aldehyde reduction, ketone, carboxylic acid or ester. So we can reduce any of this by using LiLH4. But we cannot reduce carboxylic acid and ester by using sodium boron hydride. Sodium boron hydride can reduce only aldehyde and ketone. So this thing is very, very important, right? So you must remember this thing. समझ आया सबको मैंने क्या बोला अभी? Everyone got it? Everyone got it? What is the selectivity nature of aluminum hydride, lithium aluminum hydride and sodium boron hydride? We use lithium aluminum hydride for the reduction of all these four processes. That is either carboxylic acid, ester, aldehyde or ketone. But we cannot use sodium boron hydride for carboxylic acid and ester. Sodium boron hydride can only reduce aldehyde and ketone, right? So this is selectively reduced. Now, aldehydic and ketonic carbonic group in presence of carboxylic acid or ester function. So some compounds, some example below illustrate the use of this reagent. Like we have a, we have a carbonyl compound, and when this treated with NaBH4, they will convert into butane 1-ol. Similar, we have a cyclohex-2-enol. This is also a ketone. So this ketone, in presence of LLH4, they can also convert into enol form, right? So this will be takes place. Now, this reaction is very, very, very important. That is from aldehyde and ketone using Grignard reagent, right? So this is very important. But how will you prepare alcohol using aldehyde and how will you prepare alcohol using aldehyde and ketone? So by use of the Grignard reagent. So this is very, very important. So by the use of Grignard reagent, we can prepare different types of alcohol, like primary alcohol, secondary alcohol, and tertiary alcohol as well. Let's see how will you prepare, right? So let us assume if we have a carbonyl compound called formaldehyde, right? So for the formaldehyde, we have a 2H, right? So this is called formaldehyde. Remember this. And this formaldehyde react with the Grignard reagent, that is CH3, and this is Mg, and this is nothing but Br. So this is the formaldehyde and this is CH3-MgBr, that is called Grignard reagent. So this MgBr out of this and this CH3, this CH3 having negative charge and this MgBr has a positive charge, right? So this CH3 act as a nucleophile in this reaction. We all know that what is nucleophile, right? Nucleophile, we all know, having negative charge and tendency to donate electron is known as nucleophile. Now, if I'm talking about the carbon and oxygen, obviously oxygen having more electron activity. So they have a strong tendency to attract the shared pair of electron towards itself. So they just want to attract the shared pair of electron, that is the double bond, loosely bounded electron towards itself. So here carbon feels some deficiency of electron, carbon have become partial positive. So if the carbon become partial positive, it means carbon become electrophile. They want some nucleophile to attack, right? Because they want some electron, because they feel electron deficiency, right? Why they feel electron deficiency? Because they are attached to the oxygen atom and oxygen having more electron activity and they wants to, take the electron towards itself. So here this CH3 comes into the picture because this CH3 acts as a nucleophile. So this CH3 directly attacks to this carbon atom. What will take place? So this is H, and this is nothing but this CH3 comes into the picture, right? This CH3 comes into the picture. And this we have O and this MgBr, right? In the next step, just do the hydrolysis. Just do the hydrolysis. So we know that water having which part? That is OH negative, NH positive. So what will take place, beta? That is nothing but CH3 and this is CH2 and this is O and H. And this Mg, Br and OH will be removed. So what you will get, beta? You will get primary alcohol. So if we treat formaldehyde with the Grignard reagent, you will get what? You will get the primary alcohol, right? Understood? If you treat formaldehyde with the Grignard reagent, what you will get? You will get primary alcohol. Similarly, if what happen if you treat aldehyde? So if you treat aldehyde, what is aldehyde? That is CH3. So if you treat aldehyde with the Grignard reagent on the same mechanism, this CH3, this is Mg, this is Br, this CH3 acts as a nucleophile, this again wants to take the electron, this CH3, yeah, just like the previous mechanism. So this will form, what they will form, beta? So this is H, this is again CH3, this CH3 attached to this carbon, this become O, Mg, and this is nothing but Br. Now again, hydrolysis, so what you will get? You will get CH3, CH, OH, and this is again CH3 plus Mg, Br, and OH. So what you get? Secondary alcohol, right? So when you treat aldehyde with the Grignard reagent, you will get the secondary alcohol. Clear as So when you treat formaldehyde with Grignard reagent, you will get primary alcohol. And when you treat aldehyde with the Grignard reagent, you will get secondary alcohol. Now, what about ketone? What happened in case of ketone? So now we have a ketone, right? We have a ketone and we treat this ketone with Grignard reagent on the same fashion, right? Same manner. We know this. This become partial positive and this is nothing but partial negative. So this CH3 attached to this carbon atom, what they form? They will form CH3. This is C. This is again CH3, right? And this is nothing but O, Mg and Br. This CH3 comes into picture. So this CH3 comes into the picture. Now, upon hydrolysis, what they form? They form CH3, C, again CH3 we have, again CH3, and this is nothing but OH, right? And this is Mg, Br, and OH. So we get the tertiary alcohol, right? So from carbonyl compound, by treating carbonyl compound with the Grignard reagent, we are able to produce both, or we say all of the alcohol, that is primary alcohol, secondary alcohol, and the tertiary alcohol, right? I hope this is clear to all of you, that how will you prepare primary, secondary, and tertiary alcohol by using the Grignard reagent. सबको clear है क्या? एक बार जल्दी बता दो फटाफट मेरे. Quickly tell. Is it clear to everyone? How will you prepare primary, secondary, and tertiary alcohol? By using Grignard reagent? Yeah. GNV Rajkot. Yeah, good. Right. So this is the method. How will you prepare this? Sure. Good. Yeah. Now, this is very important, right? So this is what we do. Like when you treat with the methanol, we'll get butane 1-ol. When you treat with the ethanol, that is aldehyde, we get butane 2-ol. Huh? Okay. Similarly, when you treat while with ketone, Grignard reagent give tertiary alcohol, right? So these three we already discussed. So remember, very important thing here, one notable point. From the aldehyde and ketone, that is from carbonyl compound, we have two ways for the preparation of alcohol. Either, that is the third method, by treating with the reducing agent. So when we treat with the reducing agent like LiLH4 and NaBH4, we are able to produce primary and the secondary alcohol, right? Like when you treat aldehyde, then we'll get primary alcohol. If you treat ketone with the reducing agent, we'll get the secondary alcohol. Now, again, when we treat carbonyl compound with the Grignard reagent, instead of reducing agent, now this time we are taking Grignard reagent. Then we'll get primary, secondary, and tertiary. So all type of alcohol we obtain. Okay, sure. Now, the last method and one of the important method is like a fermentation, right? So this is also a very important method, fermentation. So ethanol is prepared on a large scale using fermentation, right? So it involves breaking down a large molecule into a simpler one using an enzyme, right? So ethanol is prepared on the large scale. For the large scale industrial preparation, we use this method, fermentation, right? So it involves breaking down a large molecule into a simpler one using enzyme. Usually yeast is added as a source of enzyme. Now, the fermentation of sugar is shown below. So how will you prepare this? Now we have a sugar, right? So when you treat sugar with the, or we say hydrolysis of sugar will take place in the presence of enzyme called inversive, right? So in presence of the enzyme, this will break into glucose and fructose. Now again, this glucose and fructose is break by the help of the enzyme called gymase to form ethanol and CO2, right? So this will form ethanol. So this is called fermentation. That is the hydrolysis of sugar. So we'll get glucose and fructose. And by the reaction with the glucose and fructose with the enzyme called gymase, we are able to produce ethanol. So this is another method for the preparation of alcohol. Now, we have covered all the important method of preparation for the alcohol. Now quickly see the structure and physical properties of alcohol. So the structure of alcohol is similar to that of water. Just in case of water, we have a 2H and 1O. In case of alcohol, instead of 1H, we have one R, that is alkyl group, right? So this is the structure of water, and this is a structure of the alcoholic group, right? So the structure of water and methanol molecule is shown in the figure. So this is all about the structure of ROH. So for example, we have a R, O, and H. In case of water, we have a H and OH, right? So just in place of R, we have a H in water, right? Now, normally hydrogen bonding is responsible for the higher boiling point of alcohol. So we all know that alcohol show higher boiling point, right? Higher solubility, and only one reason behind this is the hydrogen bonding. So normally only the hydrogen bonding is responsible for the higher boiling point of alcohol. Now, hydrogen bonding among this alcohol molecule is depicted in this figure. We can see that this is the hydrogen bonding. So, what is the hydrogen bonding basically, beta? We know that in case of alcohol, we have a group like ROH, right? So, we have a group like R, and this is nothing but O, and this is H, right? Now, this O is partially negative, right? And this O is partially negative. So, they want to attract the positive charge. So, again, if we have a 2, if we have a 2, so again this oxygen is negative, this field partial positive, so here is a bond between this oxygen and this hydrogen. So this is called the hydrogen bonding, right? Again this will form bond with this H, O, and again R. So this will continue. So this is known as hydrogen bonding. So due to the hydrogen bonding among alcohol molecules. So here hydrogen bonding takes place among the hydrogen molecule. We all know that what is hydrogen bonding? Hydrogen bonding means only these three elements, phone. Always remember this name as phone, right? Phone, F-O-N. So only these three elements having capacity to form hydrogen bonding. Why only these three elements? Because these three elements only having more, electronegative value than this hydrogen. So only these three elements, that is F, O, and N, having capacity to form hydrogen bonding. So here we have O. So that's why hydrogen bonding will be formed, right? In case of HF, in case of NH3, we all, in this case, we get the hydrogen bonding. So hydrogen bonding means hydrogen bond, which when hydrogen bonding is formed. So hydrogen bond is formed only when these three elements are present, like FON, right? So only due to presence of these three elements, hydrogen bonding will be formed. I hope this is clear to all of you. Chal. Now, so if you are going to talk about the acidic and basic behavior, right, of alcohol. So what is the acidic and basic behavior of alcohol? So alcohol behave both as acid and base. They are weakly acid, right? So if I'm talking about the acidic character, if you want to compare, so they are very weak acid, right? Even weaker than water, right? So if you want to compare the acidity of water and alcohol, then you find alcohol is much lower acidic than water itself, right? So they are very weak acid. A strong base such as a hydride ion H negative in the sodium hydrogen NaH can remove the proton from the alcohol molecules and an alkoxide ion result. So this is the evidence that alcohol is acidic in nature. Whenever the alcohol is react with the base, that is alkoxide ion will be formed, right? Similarly, this is the example, this is ethanol, and when this react with the base, right, the ethoxide ion and protonated base is formed. This will suggest that that is alcohol is acidic in nature. So when the water is used as a base, the acid dissociation constant Ka and pK can be written. And so we can write the value of Ka. We all know this thing in the equilibrium chapter. That is how will you write Ka. That is a acidic dissociation constant. So acidic dissociation constant is nothing but the product, that is the concentration of the product divided by the concentration of the reactant, right? Now pK is always minus log of the Ka. This all we know that, right? So here are the some pK values are listed below. So if talking about the methanol, they having the pK value 15.5. What is this pK? So this pKa value is inversely proportional to Ka value. Always remember this, right? So this pK value is inversely proportional to Ka value. Higher the value of Ka, higher will be the acidic. Always remember this thing, right? And higher the value of pKa, it means lower the value of Ka, right? So methanol having higher pKa value, 15.5. It means, they have a very low Ka value. Similarly, this is an H2O. So if you're talking about the H2O and methanol, which having more pK value. So H2 having more pK value, right? That is 15.74. This is 15.5 approx. So higher the value of pKa, lower the value of Ka, and lesser will be in the acidic character, right? So this is all about. Now remember that the lower the pK value, I already told you, lower the pK value, higher is the acidity of that compound. Okay? Alcohol can behave as a weak base also. They have the lone pair of electron on the oxygen atom, right? So in the structure, we can see that they have a lone pair of electrons on oxygen atom, and hence they can be protonated by a strong acid to give oxonium ion, as shown in the figure, right? So we have an alcohol that is ROH. We have a lone pair of electrons. So this having lone pair of electron, so they can also behave like a electron pair donor. So the alcohol can also behave as a weak base also, right? Now, here okay, we can say that the formation of alkoxide will take place. Like we have alcohol, when this react with the active metal like sodium, then alkoxide and hydrogen gas will be removed. So this removal of hydrogen gas will be ensure that alcohol are acidic in nature, right? So alkoxide are used in the synthesis of many organic compounds, right? Okay, so in the conversion of alkyl halide also, we have like 2-methyl propane to all, and when this react with the HCl, they will easily convert this into a propanol, right? That is a 2-chloro-2-methyl propane. So in the conversion to alkyl halide, so if you want to convert alcohol to alkyl halide, remember this thing. If you want to convert alcohol to what? Alcohol to haloalkane. So we can use this method also, right? So like propane 1-ol when treated with SOCl2, they will easily convert it into 1-chloropropane, right? They're easily converted into 1-chloropropane. So these all are like whenever we treat alcohol, let me write here. Whenever we treat alcohol, that is ROH, with the following reagent. Which following reagent, beta? Either with ZnCl2 and HCl, with PCl5, with PCl3, and with SOCl2. So out of these four methods, all these four methods can convert alcohol into alkyl halide, right? They can convert into alkyl halide. Always remember. So out of this four method, this SOCl2 method is a very best method. We already discussed this thing in alkyl halide chapter, because in this the product what we get is this is alcohol plus HCl plus SO2, and both are vapor, so they can easily separate. So this method is very useful, right? This is the best method for the preparation of alkyl halide from alcohol. So whenever we treat alcohol by this following reagent, either with the ZnCl2, HCl, PCl5, PCl3, and SOCl2, we always get alkyl halide, right? So I hope this is clear to you. Now, this Lucas test is also very important. That is the this Lucas test. This is this one. That is the first one. ZnCl2 and HCl. This is itself termed as Lucas reagent, right? So this is known as a Lucas reagent. Always remember this thing. This is known as a Lucas reagent. So this Lucas reagent is very important. The formation of alkyl halide from alcohol is on the basis of this test, and it involves the reaction of the alcohol with the Lucas reagent. What is this Lucas reagent? Lucas reagent is nothing but anhydrous ZnCl2 plus concentrated HCl. So if we are talking about the reactivity of the alcohol with the Lucas reagent, that is primary, secondary, and tertiary. So remember this, tertiary alcohol reactivity is very much, as primary alcohol reactivity is very low. So this Lucas reagent test is basically used for the distinguish between primary, secondary, and tertiary alcohol, right? So if you have to compare or distinguish between the primary, secondary, and the tertiary alcohol, you use this test, Lucas test, right? What happened if you treat a primary alcohol with the Lucas reagent? So if you treat primary alcohol with the Lucas reagent, then no reaction will be takes place. Now, if we took the secondary alcohol and react and try to react with the Lucas reagent, then reaction will be takes place in the 5 minutes, right? Approximately in 5 minutes. Similarly, if you want to treat tertiary alcohol with the Lucas reagent, then the reaction immediately takes place, right? So we can also say that like if you treat primary alcohol, no turbidity will be formed. If you treat secondary alcohol, turbidity appears after 5 minutes. And if you treat tertiary alcohol with the Lucas reagent, then turbidity appears immediately. So this is all about that. How will you prepare? How will you react this Lucas reagent with the different alcohol? So reactivity of tertiary alcohol is very more as compared to primary and secondary, right? So this is all about the Lucas test. So I hope this is clear to all of you. Okay. So आज हम लोगों ने सब डिस्कस कर लिया. सो इन द नेक्स्ट क्लास वी आर गोइंग टू डू सम क्वेश्चंस, राइट? So we are going to do some questions like this: hydroform test, can vector Meyer test, most suitable reason. So this all we are going to do in the tomorrow class. So for in tomorrow class we are going to do questions related to this alcohol method of preparation and their physical and their chemical properties only. Right? Anyone having any kind of doubt? Or we close the session? किसी को कोई डाउट नहीं है? या यस सर. ओके. सो ठीक है, कल करते हैं, कल मिलते हैं, एंड देन वी आर गोइंग टू स्टार्ट solving some questions related to this chapter, right? So take care, all of you.